In this video, we are going to have a short tutorial on distillation, type of distillation, and how it aids in separation of mixtures, as well as the various examples of mixtures which can be separated by distillation. Don't forget to subscribe to the chapter version so that you can be a big follower of this channel. So distillation is basically a separation technique that separates mixtures by heating. It separates mixtures to derive both components of the mixtures. So example for evaporation, when you separate a mixture, you get one component and the other is lost. But in distillation, we separate the mixture and we at the end get both components of the mixture. It can also be used to purify a particular impure substance. For example, let's say you want to have a pure sodium chloride mixed with, let's say, ethanol or water. Upon distillation, you'll get the pure crystal of the sodium chloride. You basically have two types of distillation. You have simple and fractional distillation. Both have similar setups but have slight differences in them in terms of their functions and uses. So let's begin with simple distillation and we go to fractional distillation. So this one is simple distillation setup. Very simple, as the name implies. It's very simple, used to separate mixtures. This setup can be used to separate various types of mixtures. One, it can be used to separate a mixture of, let's say, insoluble solid in liquid, or let's say insoluble solute in a solvent. Let's say if you have a stone or gravels in water, this setup can be used to separate the mixture. It can also be used to separate a soluble solute in a solvent, or let's say a soluble solid in a liquid. Let's say if you have crystals of sugar or crystals of sodium chloride mixed in water, it dissolves, and that mixture can be separated by simple distillation setup. If you have two setups, or let's say two mixtures of immiscible state, or two mixtures of a very wide boiling point rate, let's say a mixture 1 and a mixture 2, they have different boiling point of a very wide range. Let's say a mixture of, let's say, water and oil, they have very wide boiling point range. So this mixture can be separated by simple distillation method. So let's look at the setup of the simple distillation. The setup or the separation technique is done by heating. So the first one is the heater, which can be done by electric heater or a Bunsen burner. So the first setup of every distillation is a heater or heat source, which can be an electric heater or, let's say, a Bunsen burner. Up here is a flask, most importantly round bottomed flask. So in the flask is the mixture. See here, you have a mixture of, let's say, your solid particles and your liquid. Let's say you have stones or gravels immersed in water, and you want to separate the water from the gravels. So you have here the water and the gravels in here. Immersed in the flask is a thermometer that measures the temperature at which the liquid component evaporates from the entire mixture. Most setups have the thermometer connected to the flask by a cork. So let's say a cork, this is a cork. The thermometer is connected to the flask by a cork in most setups. Connecting the flask to the condenser is an adapter. So here we have a distillation adapter, which is here. So this is a distillation adapter that connects the flask to the condenser in most setups. The next one is the condenser itself. As the name implies, it condenses because it converts the vapor state of the liquid here into liquid form. This is a condenser that condenses or changes the liquid or the vapor state, the gaseous state of the liquid, to the liquid form. The condenser has two main parts. It has an inlet and an outlet. The inlet is where you add water to cool the vapor, and the outlet is where the warm water exits from the condenser. Next is the receiving flask. The receiving flask is most important, flat bottomed flask. This is the receiving flask that receives the condensed vapor from the condenser. And the condensed vapor here is called the distillate. The distillate. So this here, the water component of this mixture is received here as the distillate. So this is a very simple setup for say, simple distillation. Let's see how fractional distillation differs in this. In terms of function, fractional distillation is used to separate mixtures. Importantly, two miscible mixtures are very close, boiling point. Let's say if you have a mixture of let's say you have ethanol and water, and you want to separate this mixture, a mixture of alcohol and water, because they are miscible mixtures and they have not wider boiling point range. What you want to do, you have to use a fractional distillation, so it separates the mixtures based on fractions. The only difference between the simple distillation and the fractional distillation here is the use of the fractionating column present in the fractional distillation. So it uses a fractionating column. This is a column which is a fractionating column, which allows the mixtures of the various components of the mixture, which all evaporate, to move up here at different rates and prevent them from mixing. So here they are all liquids and they all evaporate. So when they get here, they all move at different rates, and the fractionating column prevents them from getting mixed. Similar to the simple distillation, all of this has a tripod stand, it has a retort stand and a clamp. So it has a tripod stand. The tripod stand is where you put the bottom flask on, then you apply the heat source, which is the Bunsen burner here. It has a retort stand and a clamp that holds the flask onto the fractionating column in position firmly. It has a distillation adapter, as we said here. It has a distillation adapter. The adapter connects the fractionating column to the thermometer here. It has a cork that connects the the distillation adapter to the thermometer. The thermometer here measures the temperature at which the various components of the mixtures evaporate. It has, as we said here, a condenser, an inlet, and an outlet that condenses the vapor state of the liquid to the gaseous state back. So here, the mixture with the lowest boiling point is collected first than the other. So let's say you have a mixture of ethanol and water. Ethanol boils at a temperature of 78 degrees and water boils at 100 degrees. So it means at a temperature of 78 degrees, all the ethanol components of this mixture is going to be evaporated and will be collected first here. So here there's an adjustment. You have to adjust the heat so that it does not exceed much, or it does not reach the 100 degrees Celsius. Let it be around 78 and 80, so that all the ethanol here will be collected first in the flask, and at the end you have the water left in the round bottom flask and the ethanol in the flat bottom flask. So it's very simple. The only difference between this one and the fractional distillation is that the simple distillation is that in the fractional distillation it uses a fractionating column to separate the mixtures because they all have a close boiling point. So fractional distillation, the vapor of lower boiling point fraction reach the top of the column first, followed by the vapors of the higher one. So we have here the vapor of the lower boiling point here is the ethanol, so it reaches the top of the column here before that of a higher boiling point, that is the water. So that's a very simple apparatus, a simple setup for this direction. So it is flown here from the heat source. The one with the lower boiling point flows first to the condenser, then to the receiving flask. Thanks for watching. Don't forget to subscribe to the channel and like. Thank you.